Buenas tardes a todos. Buenas tardes a todos los que estáis viendo a través de YouTube. Gracias por uniros a este meetup, a este webinar. No sé llamarlo meetup porque me falta las cañas de después y el poder estar charlando un rato con vosotros. Al final es lo que ¿no? la esencia del meetup, pero bueno, este webinar en el que vamos a intentar introducir una tecnología que Oracle lleva varios años trabajando y posicionando muy fuerte, GraalVM. Espero que a algunos os suene. A los que no, también pues intentaremos introducirlo para que podáis entender bien toda la potencia que hay detrás de esta tecnología. Lo primero de todo, pues eso, presentarme. Yo soy Borja Gómez, trabajo en el área de desarrollo de negocio en Oracle. ¿Vale? Y conmigo también va a estar Oleg Selajev, que es del equipo de Product Management, es Developer Advocate de GraalVM. ¿Vale? O sea, él es, digamos, el experto que está con nosotros aquí para hablarnos. Más adelante le introduciré. I will introduce you later, Oleg, if you don't mind. Como hemos querido hacerlo así, pues para poder hacer una introducción también en castellano y también para pues, quedar yo quizás de punto de entrada para si luego pues tenéis algún comentario que hacer o alguna pregunta que queráis hacer, pues podamos seguir en contacto, ¿vale? Y Oleg pues, estará con nosotros explicándonos pues desde la experiencia, tanto la parte de utilizar frameworks como el uso del estado de algunos frameworks, algunas experiencias con proyectos, etcétera, irá comentándonos más adelante. ¿Vale? Y también quiero agradecer a Paradigma la invitación para participar en este meetup y por seguir pues eso, impulsando también pues el que se hable de este tipo de tecnologías quizás pues, más emergentes, ¿no? Dentro de este meetup de Emerging Technologies y también del desarrollo con frameworks como Spring para que siga pues avanzando y podamos seguir reuniéndonos, ¿no? La gente pues que estamos interesados en esas tecnologías. Antes de nada voy a pasar rápidamente por una pequeña slide legal para que, bueno, que es siempre en Oracle para que no compréis nada basándose en algo que pueda decir de futuro algunas fechas que puedan no estar exactas. Como os decía, yo soy Borja Gómez, aquí tenéis mi LinkedIn, ¿vale? Luego os pondré también mi correo por si queréis preguntar algo, ¿vale? Y ya entramos en detalle en qué es GraalVM, ¿vale? ¿De qué estamos hablando hoy? GraalVM es una máquina virtual de alto rendimiento, políglota, para cargas de trabajo modernas, especialmente pues para carga de trabajo también, sobre todo en la nube, ¿vale? En desarrollo en cloud. Ahora voy a entrar un poquito más en detalle, ¿vale? De las tres partes que he dicho, que es una máquina virtual de alto rendimiento y políglota, ¿no? Porque al final, bueno, pues son las grandes, digamos, apuestas o las tres grandes características de GraalVM. La primera de todas es que, como digo, es una máquina virtual de alto rendimiento que permite correr cargas de trabajo de Java, ¿vale? Sustituyendo la máquina virtual de Java que tenéis, se llama modo hotspot, ¿vale? Es la máquina virtual que corre sobre la instancia o la máquina que estáis utilizando y sobre la que se ejecutan las aplicaciones de Java, ¿vale? Esto es lo que llamamos el just-in-time compiler, ¿vale? El just-in-time significa que la máquina virtual está corriendo al igual que corría la máquina virtual de Java y sobre esa pues se van, digamos, ejecutando las aplicaciones que quieras correr, ¿vale? Esto en tiempo de ejecución en el que se decide pues, las clases que tiene que ir cargando y demás, ¿vale? Luego hay otro modo que es el modo ahead of time, ¿vale? Que es el ahead of time o native image, ¿vale? El compilador, que este es un modo distinto. En este caso no es que se sustituya la máquina virtual de Java en sí, sino que el GraalVM lo que hace es compilar y hacer un análisis de toda la aplicación, ¿vale? Que vais a correr y luego compilarla a código máquina, ¿vale? Para el despliegue y el desarrollo y el despliegue para la máquina que vais a utilizarlo, ya sea en Linux, en Windows o incluso en Mac, ¿vale? Esto normalmente, hombre, lleva más tiempo el despliegue, ¿vale? Es decir, lleva un tiempo un poquito más largo el despliegue, lo que es la ejecución, la compilación, que una compilación normal, porque al final lo que hace es hacer un análisis muy exhaustivo de todo el código de tu aplicación para poder cargar solo aquello que tiene que cargar y optimizando de una manera muy grande la ejecución, ¿vale? De esta manera lo que tenemos es una reducción muy, muy grande del tiempo de arranque, estamos hablando de muchos órdenes de magnitud, es decir, no estamos hablando de un 10%, un 15%, sino que estamos hablando ya de unos órdenes de magnitud bastante grandes. Luego veremos algunos números, ¿vale? Y también el consumo de memoria o la memoria que necesita para ejecutar las aplicaciones, ¿vale? Esto luego ya entraremos un poquito más en detalle, pero en el mundo en el que estamos yendo, en el que al final estamos yendo a un cloud y a un pago por uso, ¿no? En el que al final configuras las máquinas para que corran tus cargas de trabajo en función de lo que necesites y además puedes escalar y puedes escalar prácticamente en cuestión de segundos y demás, pues el reducir tanto el tiempo de arranque para poder escalar de una manera casi en el momento, ¿no? No dinámica, o sea, no previamente con un tiempo de calentamiento, etcétera, sino tener en el momento que la precisión es muy alta, pues tener la capacidad para poder responderla, pues es muy importante y también con un consumo muy pequeño de memoria y, por tanto, un ahorro importante, ¿vale? Y luego, como tercera característica, os decíamos que era deseada políglota, ¿vale? Eso significa que puedes correr ya no solo código Java, sino que a través del API, de un API que tiene nativo GraalVM que se llama Truffle, ¿vale? Que genera a través de este API una traducción, digamos, de todos estos lenguajes, ya sea JavaScript, ya sea Python, sea cualquier lenguaje de la LLVM, C, C++, incluso R o Ruby, por ejemplo, ¿vale? Todo todos estos lenguajes, aplicaciones en estos lenguajes pueden correr sobre GraalVM, ¿vale? Esto significa que al final pues podemos llegar a utilizar piezas de código que tenemos de otras aplicaciones, por ejemplo, y en vez de tener que hacer una comunicación entre distintas piezas, pues poder integrarlo todo, incluso poder utilizar librerías que están en otros, yo qué sé, pues por ejemplo, una librería de visualización de datos, a lo mejor de R o de Python, que conocemos bien, que funciona bien y queremos incluirla en un servicio con Java o con JavaScript, ¿no? Todo esto de una manera pues bastante sencilla y luego veremos algún ejemplo. No es quizás una capacidad para usarla en el día a día o todos los días, pero desde luego es algo que es bastante interesante, ¿no? Y sobre todo, pues eso, bastante apetecible también de probar, ¿no? Al final esto no deja de ser un mitad también de tendencias de tecnología en la que no solo aquello que tiene quizás voy a utilizar en mi día a día del trabajo, sino que también aquellas cosas que, bueno, pues que me gustaría probar, ¿no? Comentaros también que hay dos versiones de GraalVM. Hay una de ellas que es la Community, totalmente gratis, ¿vale? En la que podéis utilizar para cualquier tipo de propósito, ¿vale? Podéis correr cualquier programa que corra en GraalVM Enterprise, lo puedes correr también en GraalVM Community. Y luego hay una versión Enterprise, pues con soporte, con unas optimizaciones a nivel de performance, a nivel de escalabilidad y seguridad, pues también importantes y que, bueno, está basada también en las versiones de Java, la 8, la 11 y la 16 y podéis utilizarlo. Y también si tenéis la suscripción ya de Java Enterprise Edition, Standard Edition, perdón, pues podéis también utilizarlo porque va incluido, ¿vale? Y también deciros que si utilizáis una instancia de cómputo de Oracle Cloud, ¿vale? Que no sé si lo conocéis, una instancia de cómputo, cualquier instancia de cómputo incluye la versión de JDK, incluye, por tanto, también GraalVM, ¿vale? Con lo que tenéis ahí pues la posibilidad de usarlo también a nivel profesional y empresarial, ¿vale? ¿Qué resultados tenemos? ¿Por qué me puedo meter yo a meter esta tecnología, ¿no? Es decir, que me va a sustituir la máquina virtual, que me va a cambiar, que me va a hacer, bueno, meter un grado de incertidumbre, ¿no? en mi ecosistema de IT. Bueno, pues la realidad es que los resultados que tienen ya solo en Just in Time, que es, por ejemplo, lo que veis aquí, ¿vale? En este caso, hemos puesto aquí la versión digamos, el rendimiento de lo que es la OpenJDK, ¿vale? En este caso la 11, ¿vale? Sería la base de la línea en un 1, ¿vale? Sería el rendimiento que tiene y utilizando Renaissance, el benchmark de Java, que es uno de los más pues yo creo que reconocidos y más usados, se ve un incremento en las distintas pruebas bastante importante, ¿no? Bueno, pues tenéis alguna de ellas, el Geoman, por ejemplo, que es bastante conocido sobre utilizar, pues un rendimiento de hasta 1,5 veces, ¿vale? Tenemos algunas de hasta 3 veces. Al final la mejora de rendimiento es bastante grande y ya os digo que simplemente es sustituir una pieza por otra, ¿vale? En el caso de que nos metamos ya en el tema de imágenes nativas, el ahorro, como os decía al principio, es muchísimo más alto, ¿vale? En este caso, hemos hecho la comparativa de 3 aplicaciones de ejemplo, ¿vale? Utilizando Helidon, Micronaut y Quarkus, tres frameworks de desarrollo de microservicios, bueno, pues que de alguna manera compiten pues en un espectro de lo que son pues quizás entre los microframeworks y los frameworks quizás más grandes, como por ejemplo puede ser Spring, ¿no? Que es quizás más complejo, más completo, más grande, con más librerías, ¿no? Al final hay unos microservicios o unos frameworks de microservicios pues quizás un poquito más contenidos, con una funcionalidad un poco más limitada a lo mejor, pero bueno, también bastante interesantes, como estos tres que os ponemos aquí, y hemos hecho la prueba porque compiten, digamos, en igualdad más o menos de oportunidades, ¿no? Como veis, en la escala verde tenéis el tiempo de arranque de la aplicación utilizando la JDK8, ¿vale? La versión de Java estándar en el modo hotspot. Y si nos pasamos a la imagen de Native Image, como veis, todos ellos se reduce, pues eso, desde un 40, un 50, un 60% hasta un 90 veces, ¿no? Es decir, al final, no 40%, sino 40 veces. Es realmente una mejora de rendimiento muy, muy importante, ¿vale? Al final, como os digo, esto no es para tenerlo en cuenta como tal, es simplemente un ejemplo, son ejemplos, digamos, de las aplicaciones más o menos estándar, ¿vale? Con una serie de módulos incluidos, pero no es una aplicación, digamos, habría que ver qué módulos vamos introduciendo y qué capacidades vamos incluyendo de estos distintos frameworks que al final, bueno, pues más o menos podemos ir aumentando, ¿no? También la complejidad, subirá un poquito el tiempo y subirá un poquito, pero al final lo que es el aumento de rendimiento se sigue manteniendo, ¿vale? En las pruebas que hemos hecho y en algunos clientes que lo están utilizando a nivel profesional, lo están utilizando en producción, pues se siguen viendo unas mejoras muy sustanciales, ¿vale? Como veis aquí también es muy importante, y esto sí que es sin ningún tipo de optimización, simplemente por la compilación de imagen nativa también de lo que es la huella de memoria que utilizamos, ¿vale? Y esto es lo que os decía, al final, pues fijaos, pasar de 200 megas a 37 megas, al final lo que significa es que básicamente mi instalación de mi Kubernetes o de mi ya sea on-premise o en la nube, etcétera, o incluso mi aplicación serverless, ¿vale? Que pueda tener, pues pasamos de tener un consumo de memoria de 200 megas a tener, pues eso, 5 veces menos, ¿vale? Al final esto significa un ahorro importante, tanto en recursos pues como en infraestructura como en coste, ¿vale? GraalVM, en la parte de Native Image que estaba comentando, ¿vale? Que quizás es la más interesante, yo creo, desde el punto de vista también de desarrollo, por las grandes mejoras que conlleva, pues trabaja muy bien no solo como os decía, con Helidon, Micron o Quarkus, ¿vale? Que es la base, digamos, de la parte de la compilación nativa de estos frameworks, que seguramente hayáis oído hablar de ellos, pero también, por ejemplo, trabaja con Spring, ¿vale? El trabajo en Spring, hay una línea de trabajo que luego les comentará, que es Spring Native Image, que al final es digamos, pues la adaptación y la homologación de todo el trabajo de Spring para poder compilarse de manera nativa y poder beneficiarse de todas estas mejoras que necesitamos, ¿vale? Por supuesto, también es ideal para trabajar con contenedores. Esto no, pues, al final no deja de ser algo que reduce el tiempo de arranque, reduce el tiempo, el número de recursos, con lo que al final pues nos acerca mucho más al paradigma de despliegue en el cloud, en el que al final tenemos un modelo elástico que escala en función de las necesidades y que además es pago solo por lo que necesito y además, bueno, pues de alguna manera contengo los costes, ¿no? de mi infraestructura, ¿no? Que es al final lo que todos estamos buscando, ¿no? En muchos de los casos. Si ya hablamos del throughput, ¿no? De lo que es el rendimiento, pues podemos ver aquí, en función de cómo van aumentando el número de llamadas, si os fijáis aquí la línea roja es GraalVM en modo nativo, ¿vale? Al final, como veis, el throughput es prácticamente constante, es muy alto desde el principio, ¿vale? En función de las... según a partir de un nivel de peticiones es un poquito más alto en modo just in time, ¿vale? Como veis aquí, pero siempre es superior o igual al de la JDK, ¿vale? En este caso. Y al final una cosa importante es que, bueno, es lo que, como venimos comentando todo el rato en la presentación, todo esto significa al final un ahorro de costes. Al final todo este gap que llenamos en este sentido es menos infraestructura que necesito, más peticiones que puedo aceptar y al final no deja de ser pues una optimización en términos económicos y también en términos de rendimiento, ¿no? de mi infraestructura y de mis aplicaciones, que al final es lo que estamos buscando también, ¿no? Nosotros esto lo llevamos usando Oracle Cloud Infrastructure, ¿vale? En nuestro cloud, y hemos visto pues unas mejoras de un 10% en las transacciones, ¿vale? Como os decía, perdonad, lo estamos usando en modo just in time, ¿vale? No en modo native image, porque no todo está adaptado para utilizarlo en modo native image, simplemente sustituir la versión de Java por el GraalVM, ¿vale? Enterprise Edition, en este caso, la 19.1, es la que estaba cuando se hicieron esas pruebas y demás, y bueno, después de 30 millones de horas de pruebas y demás, no hubo ningún issue, ¿vale? Es 100% compatible, y la reducción, por ejemplo, del tiempo de garbage collection pues fue un 25%, ¿vale? Al final son unos números bastante interesantes y que, bueno, pues que yo creo que nos puede animar a darle una oportunidad, ¿no? Y a echarle un vistazo, ¿no? Como os decía, al principio había 3 partes, una de ellas era la sustitución de la JDK para utilizar el modo just in time. La siguiente era el modo nativo, ¿vale? Que, como comentaba, pues es quizás esta funcionalidad más interesante en cuanto a en términos profesionales, en el sentido de un ahorro importante de costes y un ahorro importante de recursos, pero también está el tema de utilizar pues, el poliglotismo, ¿no? Y a un nivel, si los microservicios ya nos hablan de utilizar, pues eso, ¿no? Ser políglota en el sentido de mi parque de aplicaciones o mis microservicios, poder tener distintos lenguajes, ya el siguiente nivel pues puede ser eso, utilizar librerías de otros lenguajes dentro de mis aplicativos, ¿no? En este caso, podéis ver aquí una función, una aplicación Node.js, ¿vale? Con su módulo de Express, que va a utilizar un tipo nativo de Java, ¿vale? En este caso Big Integer, y va a utilizar también R, ¿vale? En este caso para evaluar una función, ¿vale? Y para poder pintarlo al final, si bueno, podemos tener, pues eso, como podéis ver aquí, tenemos nuestro servidor de Node.js, ¿vale? Que está levantando de una manera muy sencilla, como sabéis, simplemente con un solo comando tienes levantado el servidor. En este caso, pintamos un número muy grande y luego tenemos aquí pues este plot, ¿vale? De R, pues que al final lo que os decía, poder utilizar librerías que quizás hacer esto a lo mejor en Java pues sería más complejo, habría que introducir una serie de librerías y sería complejo para luego pintarlo y para poder hacer una representación, etcétera, y con esto pues lo podemos hacer de una manera muy sencilla, ¿vale? Ya por último, pues comentaros, aparte de nosotros, hay otros que lo están utilizando, ¿vale? En el caso de Twitter, por ejemplo, es uno de los que, bueno, pues más famosos son, porque al final ya sabéis el número, digamos, de la infraestructura que tiene Twitter tan enorme, ¿vale? Y a las necesidades además de escalado y para adaptarse a las necesidades, pues han visto un 10% de rendimiento en performance, un 20% de reducción en la latencia, ¿vale? Al final esto es algo que al final se reduce en ahorro importante, ¿vale? Ya, antes de terminar yo y introducir a Oleg, porque creo que es el que realmente pues os va a dar más detalles, especialmente de cómo utilizarlo en los microservicios con Java, con Spring o con otros frameworks, etcétera, y algunos next steps que podéis hacer pues, para poder utilizar este producto. Deciros que, como resumen un poquito, pues que es un código que ya está 100% disponible para usar en producción, ¿vale? Tenéis aquí el enlace, ¿vale? La idea es que, pues, que invitaros a que lo utilicéis, y también hay un Slack, ¿vale? En el que podéis uniros y en el que se da soporte de alguna manera para que pues, esto no sea una prueba más que hacéis vosotros solos, a lo mejor en vuestro tiempo quizás libre o en un tiempo que no tenéis demasiado que hacer en el trabajo, asignación entre un proyecto y otro, sino que es algo que podéis incorporar también en vuestros proyectos, empezar a probarlo por lo menos, y vais a tener también pues, el apoyo, digamos, de la gente que estamos detrás de esto, ¿vale? Y ya yo no quiero robaros más tiempo, como os decía. I want to thank you, Oleg, for being here today. I will be in the backstage trying to catch all the questions for Oleg. Maybe if you have any question, maybe you can put in the chat, or even we can talk together. We can talk after that. And please, Oleg, all yours. Thank you very much.
Thank you very much. Yes, that was a very interesting intro. It was high energy, and I like that very much. Unfortunately, my Spanish is non-existent, so I will be doing this part of the presentation in English. And I'm trying to concentrate in this, the rest of the session. I will try to concentrate on using GraalVM native image technology and on the practical aspects. So if you are looking at that later, or if you're talking to someone, you kind of have the fundamental information about what's necessary and how it works and what you should be aware of and what could be your next steps and so on. right? So this would be a practical thing about native image. Let's go through that. Native image, as Borges said, is the ahead of time compilation technology. What it means is that it can take a Java application and it can produce, it can crunch that, it can analyze that, it can compile that and produce the native binary that will run directly on the required platforms. Why is this interesting? Because it offers a completely different performance profile from what you normally expect from your Java applications. And that is a very, very significant difference, right? So if you think about the normal applications, how you run them with your Java, the GraalVM is an excellent piece of software and it's very heavily optimized, but it's heavily optimized for two dimensions of what it means to be fast or what it means to have good performance. So the JIT is normally optimizing for the peak throughput. So when everything is warmed up, your application runs as fast as possible. And also the reverse of the throughput is the maximum latency. So you want to serve your business request as snappy as possible, not just to be able to serve a lot of them using the same hardware, but also to serve every individual request rapidly, right? So there are no pauses, there are no stolen requests. So every individual user has the best performance when the requests come back to you. So the ahead of time compiled binary will feature a different performance trade-off. It will have an excellent startup speed because it's compiled, right? There is no need to JIT anything at runtime. It's all pre-compiled, it's all initialized, so the application can start and run very, very fast out of the box. And it will have a lower memory footprint because specifically you can save memory by not having to JIT any code. You don't have to maintain the heavy caches for metadata about the class files. You don't have to initialize the just-in-time compiler graphs that you need to optimize things on. So you can save quite a bit of memory on every instance running the same application. And you can also save quite a bit on the packaging because when you compile your application, it can verify and it can include only the bits and only the classes and members that will be used at runtime. So the whole extensive class library, you don't have to include that, and you can compile everything and you can zip everything and you can get a very small package. Now, the combination of small packaging, low memory requirements, and excellent startup speed, the combination of those is excellent for some use cases. For example, for the cloud applications, where you want your application to be packaged in a small Docker container with just a bit of resources, that is perfect. There is just not enough resources for the JIT to kind of move slowly and compile everything and analyze everything and get to that peak throughput. But an ahead of time compiled binary can be a lifesaver there. The same is for applications that require user interaction, some command line applications and so on, where you want this rapid workload to be readily available when you just start the application. The good thing is that it doesn't only save the memory, but while memory savings are probably the most important things in the cloud context, because that's the most expensive thing in the cloud context, it also saves you quite a bit of the CPU cycles. So here you see the graphs for serving a few requests on a Hello World application using Micronaut. And you can see, first of all, immediately you can see that the memory used by the process in the ahead of time compiled mode is much smaller, right? So it's just a few requests, so it doesn't get the chance to initialize a lot, but it's around 30 megabytes, which is negligible in the Java, by the Java standards, right? But also the CPU is the red things. So we serve 3 requests here, 1, 2, 3, and you can see that the CPU only kicks in when the requests are answered. In the JIT mode, you have to do quite a bit of work in the initialization phase, quite a bit of work after we start touching the application code, because the JIT kicks in. and the GC kicks in, and then there is this initialization thing kicks in. Why is this important? Because you want to package your applications in a neat, constrained environments, so you reduce the memory available to those and also the CPU available to those. So an ahead of time compiled application can nicely run in a single CPU, I don't know, 256 megabyte container, or usually a single CPU comes with, at least on the Amazon cloud. On AWS, a single CPU usually comes with 500 megabytes of RAM. So you can nicely run the application there. But if you're running with the JIT mode, you will also not only push the boundaries for the memory, but you will also be doing quite a bit of work. So the startup will be even slower. That is one of the problems. But that being said, some use cases are better with the JIT, right? If you have long-running processes, running with the JIT is your thing. It will probably be better. And of course, you can pick the best JIT that you want, which is GraalVM. But the point is that there is the difference how you want to run your applications. And you can choose, as a developer, you can choose which performance profile you want more. Do you want to run with the JIT and enjoy the stability and maturity of the hotspot and dynamic class loading and other features of the Java language, or you want to compile to the native image and run that way? So the choice is actually yours, and you want to, like, the thing is, you want to pick the applicable way of running your applications yourself. Sometimes it's with the JIT, sometimes it's with the AOT. So we're going to concentrate on the AOT now, and I want to talk to you about some fundamental things. And this is something that people, like, it sounds easy. And now I will talk through that, and it will sound very basic. But this is something that I'm, from experience, I know people don't think about, because it's a little bit of a foreign concept for how you run your applications, right? So, but it's also very fundamental. So when you run your Java applications using the Java utility and it starts the hotspot, and your application in the form of a jar file or a collection of jar files, right? The whole thing that you run there, this process is at runtime. So at runtime, your classes are being loaded. At runtime, your classes are being executed and compiled and so on. The configuration happens at runtime. Everything happens at runtime. And this is how native image is different. So native image lifecycle is split into two phases. One of them is the build time, where you build your native image, and the other one is the runtime, where you actually run that application. And while this sounds very silly to emphasize that is the sort of many issues that people misunderstand about native image. There is the life cycle of that application. This runtime rectangle is split into two, right? And they feature different behavior, and they feature different requirements. And I want you to kind of internalize the knowledge that there are two distinct separate phases of those. They can be separated in time, so you can build your native image in your CI continuous integration server, for example, and run it later. And they can also be separated in, like, geographically, so you can build your image in the continuous integration environment, but also run it in your production environment. So very important. What happens at the build time? At the build time, your application is being statically looked at. It's being initialized, it's being analyzed, and then it's being compiled. When I say your application, what it means is actually the whole bytecode, all the bytecode that will ever be executed in your application needs to be present at the native image build time. That means your application classes, that means the libraries that you're using, that means the JDK runtime library classes, and that means the classes from the runtime components like GC that comes from the Substrate VM project from the GraalVM. All that bytecode is present, all those things are written in Java, right? So all of them are initialized and run and analyzed the same way. And what is happening there is that the static analysis looks at the code and follows which classes are using other classes, and then it runs the initialization for some classes, and then it creates the universe of the objects that were created from those initializations. And then it compiles the code and writes it out, and it also serializes the heap of the initialized objects, and it also writes it out. And that is what our executable is. It's a pre-initialized application where all the code that will ever be used is pre-compiled, and part of the data that will be used is pre-initialized and written out. That allows us the best startup that it possibly can get, and that also allows us to simplify the startup process of your application, because some data is already initialized and run. And this analysis, this blue rectangle here, runs in the normal Java process. So this is the normal invocation of the JVM on the hotspot. You can attach a debugger to it if you want. You can look at the code that is written in Java, what it is doing, right? You can configure how much resources it takes, right? So this is a normal Java process, and it outputs the binary. So static analysis means that the code is being looked at, right? The code is not being executed. So that means that dynamic features of the language, like reflection or creating proxy classes, or using GNI, or using the resources, all those things, the static analyzer cannot 100% figure out by itself, because those features are dynamic, which means that they can be in use, or you can start using them at any moment of the runtime. So that means that the static analysis cannot help with that. So you need to provide explicit configuration for those. So for example, one thing that is not mentioned here is serialization, right? You have to explicitly say which classes you're going to serialize. And it looks a fairly time-consuming and complex process, but the configuration is a very simple JSON file. And more importantly, what you can do is you can run your application with a Java agent, and that Java agent will record, when you actually use the application, it will record all the usages of those dynamic features, and it will create the configuration for you. And this is how it works. Let me just show you a very quick example. Here. So we can do into the assistant config, right? And we're gonna cut the reflection example here. Very simple class. One class consists of the two utility classes. One reverses the string that is given as an input, and one just capitalizes the string, right? And the main class here is very, very simple, right? We parse the argument that we pass to the main method, and we instantiate the class based on the arguments, and then we call a method that was passed as an argument, and then we invoke that method. So this program is fully dynamic, right? There is nothing in this application that tells us that we need to reverse a string or capitalize a string or anything like that. So what's interesting here is that, of course, I can run this application, right? For example, I can say that I would like to run it and reverse the string hello. I need to compile this application, of course, but then I can run it. And of course, we get the desired output here, right? And now when I build the native image, and this process will take just half a minute here. So I will run it. I will just want to show you that it will fail. And I'm going to talk to you about this no fallback option while it does run, right? So the no fallback option is a configuration option that we would like to include in certain scenarios. So native image, when it finds the use of the dynamic features that hasn't been configured, right? So for example, this reflection example uses reflection. But if we don't configure that, then by default, native image would look at that and say like, oh, you don't provide the configuration for this. What I will do, I will not build the native image, this ahead of time compiled artifact, but I will just link hotspot and your classes together and make it run. And the application, the result will be runnable, but it will not feature the performance profile that you want. So we include that no fallback option. So when the errors like that will appear, then the build process will throw errors as well. So now we build the example, right? And now we have this, of course, the reflection example thing here. We can run it. We can run it, and then what was that? What was our command there? Right? It was the reverser hello, and it will fail because that class is not found. Because why? Because we never actually instruct in the code that we're going to use it. So the native image analysis doesn't include that. That's the virtue, right? We don't include the necessary classes. So what we need to do, we need to call this example with the agent lib and say that native image would like to output the configuration for this invocation into that directory. So now if we look into the meta-inf directory native image, wait, we're going to look into that, right? We're going to look into that native image. You can see that there are a bunch of files that are there, right? So, and if we cat the reflection config there, because reflection config, we will see that now we're including that configuration to include the string reverser into the application, right? What we need to do, you need to run that configuration and create that configuration for all the desired workflows in your application that you want. So now you can see that we run the capitalizer as well, and we have the more configuration. If our application will have the serialization usage or something, it will be also configured. Now we can run the same native image and build that, and now those classes are configured to be used. And now those classes will be included in the final executable. And now when we're going to run this application, we will be able to use reflection on those classes for the particular things. So for calling the methods reverse and the methods capitalize, right? So we include just 2 more classes because they were configured, right? That's it, right? So all those dynamic features are configured in the same way. So if we do now reflection example, and we're going to do string reverser, and we do reverse, and we do paradigma, right? We get the desired output. And this is what I want you to remember, is that configuring dynamic features is the technical aspect of just running your application with native image. Probably you can do that while running your tests, and then you can build your native image for the further stages of the things, right? So when people say GraalVM doesn't work with reflection, that is not true. That is not true, right? Class initialization. This is another thing that people stumble upon. And this is very, very important, because problems with class initialization are harder to harder to understand, and also they are a little bit harder to resolve. We have written a couple of blog posts and articles and the docs for that, but I wanted to show you an example as well. In a nutshell, you can, before using the classes in a Java application, you need to initialize those. And they can be, since our runtime is split into 2 parts, you can also use them and initialize them at the build time or at the runtime. So for some classes, you want to initialize them at build time. For some classes, you want to initialize them at runtime. It is always safe to initialize all classes at runtime, but it is always like the performance of the classes initialized at build time will be better. Both the startup, because we don't need to initialize that class, and maybe there could be simple, simpler compiled code for that, because some checks don't need to be included. So you can control the initialization of the packages and classes. By default, classes are initialized at runtime. except some JDK class library classes. Now, many frameworks try to save and improve their performance. So they configure your classes to be initialized at build time. And they do sort of the blanket configuration where everything is initialized at build time. So when you add some classes that have to be initialized at runtime and you don't provide any config, the framework will say build time and your build process will fail with the sort of a cryptic message that, oh, like I wanted to initialize this at build time and I couldn't because of reason this and that. So here's an example, another example that I want to quickly go through. Class installation, right? I have the example here, and I think it's called main. This is the class where main class, and there are two additional classes, class A and class B. A just has a static field of B, and B has a static field for the char set. The char set here is not a mistake, or it's a carefully selected class, because by default, native image doesn't include all the char sets. You can have the char set enabled using key, like include all char sets, but by default, in the native image form, this will not be included. So if we do this, if we build this application here, right? If we build this application, let me just quickly copy the command there. I mean, like this is a nonsense thing, right? So if I do Java C main and Java main, right, it just prints out the UTF, right? Because we do that. So now if we build the native image here, and it will take a few seconds again, right? Then it will complain that UTF char set is not found. Why? Because let me show you this back again. Oh, it doesn't look like that. Let me open another SSH there. Main Java, right? So because our static initialization, all the classes are initialized at runtime. So this class, it will be initialized at runtime. So this static initializer will need to run at runtime, and the char set is not there. So that's why if we run main now, we will get an exception saying the char set is not there. So while we can resolve that using the add all char sets thing, the point here is that we can initialize things at build time, and we can initialize both of those classes at build time, and they will be initialized at build time. That means that the static initializers will run at build time, and then the char set will be picked from at the build time and serialized into the image heap. So it will run using the normal hotspot during the build time, and then at the image time, we can just retrieve that object, that UTF char set, and then it will happily run without any problems, right? So now we have that done, right? And now we run main, we can see the desired output. So this is very, very good, and this is interesting. So, but if the downside of that application, of that thing, right? Wait a second, I want to change this class. So if I do the following change here, right? Let me just open this again. Into the class A, we added the static block. Static means that it will run when the class is initialized. That creates a new thread, and then it will just sleep and do nothing, right? This thread will do nothing, but it will sleep for half a minute. So if we now do the native image thing with the initialize at build time, this process will fail. Because now when we initialize the classes, there will be an instance of a thread that is running, and we cannot serialize that. It's impossible to serialize that. So what you need to understand is that some data cannot be serialized because there is a breach, there is this separation between the build time and the runtime components, which is kind of unfortunate, because Those things include running threads, open files, open network sockets, random instances of the random, because, wait, what? How did that work? Oh, I know. I'm sorry. I looked at the wrong thing. So what we need to do, we need to say public. We need to assign this thing first. Static, right? Thread t, right? And then we need to compile this. Come on, VI, stop being silly. And we need to compile, of course, the Java code into the Java C, right? So now it will fail, which is interesting. So, and then the solution to that is, of course, to initialize class A at runtime and only class B at the build time. So we will just have this a different command line option. Why is this like, it's supposed to fail? Am I doing something wrong? So long story short, I'm not sure what is wrong with here. Thread sleeps. Right, it's supposed to fail. I'm not sure what's not updating, but I don't have time to figure it out. So the point is here, class initialization is hard. You need to figure out, you need to be prepared that there could be something that is your application specific that you need to initialize at build time or runtime. By default, we try to do the same thing, right, and initialize it safely at runtime. But you can have the configuration, and there are a number of things that the options that you want to use to kind of sort of see what's happening, debug those things. And there is a lot of materials that we've prepared to kind of help you figure out how to debug those instances of errors. But after those two, when you know that you can configure the dynamic things and that you understand that there is the build time and runtime class initialization, after that, using native image is absolutely a fantastic experience, right? And there are a number of things that you can do to optimize it even further. There is tooling that allows you to see what goes inside, which packages and which objects contribute the most. So there is the dashboard tool that you can use, and we wrote about that before. So you can see what's inside and optimize your application further. You can optimize the size of your application using the UPX utility. It will compress it, and then typically it compresses it up to, like, the result is 1/3 of the initial native image, which how you get those like 20 megabyte microservices that start up really fast, right? So you can use UPX. You can use a selection of Docker images, how you want to package your application. So normally you would use like a Slim-based image or some Slim operating system. But with native image, what you can use Distreless, which doesn't include the operating system. And it's a small base image that is something like 16 megabyte large or 19 or something like this. To use that, we recommend using this command line option that links every native library together except the libc implementation, which will be provided by Distreless. And with native image, you can even use the from scratch Docker images, which will contain nothing except your application. And then you need to build statically, so your application is fully standalone, and you build with muscle libc. Then even the libc code will be built into your image, and then you can use it from scratch. Those things have security implications. If there is no code except your application code in that Docker image, that code cannot be vulnerable. Paired with the native image being removing the unused code, that is an excellent security improvement over including a lot of code that your application is not using. If you think about that, all the dynamic features also require explicit configuration. then you can totally remove certain vulnerability issues from your applications altogether just by compiling it to native image. You cannot deserialize a random class because first, there is no serialization without config, and second, that class might not even be included in the final image altogether. So if you care about security, you might want to think about those implications. And of course, at the end, when you build this application, you can configure it to use the certain amount of memory for its heap and the configuration, and you can observe the GC running. And what's interesting, you can even pre-configure the heap size during the build. So if I'm building a command line utility, for example, I can say like, oh, I want you to use 50 megabytes of RAM, not more. And then that will be the default setting. The user, of course, will be able to override that, but by default, it will just constrain itself to like the heap size you created here. So, and you can, of course, look at the GC and then analyze whether your configuration is applicable or not. So that is good. You can address the peak throughput and latency requirements, which for the ahead of time compiled application. Remember the graph that I showed? They were not up to the levels of the JIT. So you can include the G1, GC, and you can use profile-guided optimizations where you gather the profile beforehand and then use that profile to build a very optimized image for those particular workloads. Those are the GraalVM enterprise features. And I recently wrote an article for the Java magazine where we looked at the small application and the difference between just the basic application without those things and with the PGO and the G1 GC. That was the difference was quite large, right? So 50,000 requests per second here and 73,000 requests per second here. That is almost 1/3 faster, right? So if this is 100%, this is 150% faster. So it's 50% faster, almost. But the napkin math, but you get the point, right? It can be significantly faster. And now the most exciting thing, right? So Borja showed you pictures of some pictures of the frameworks that support native image. And those were mostly the younger frameworks for which supporting native image is easier. But of course, we all know that one of the more interesting frameworks in the Java ecosystem is Spring and Spring Boot. And I'm very happy to say that the support for native image in Spring Boot applications is getting better and better and better and better. So even now, if you go to the start.spring.io, you can in the section where you add the dependencies, you can just go and there is the Spring Native. It's experimental, right? But it is there and you can include that into your application. Now, I want you to look at the documentations there. Like, so it's a docs Spring.io, Spring Native, or if you Google that, this is very interesting read, and it goes through a number of things that you need to understand, both about native image and about how it applies to Spring and Spring Boot applications. You can see that a bunch of people that worked on those, right? So including the Andy Clement and Sebastian Deluze, who are the people working on the Spring Native for quite a bit, and they contributed a lot. But you can also see there's Stephanie Cole, Josh Long, Brian, Jay, Dave, Sire, Philip, Esteban, right? A number of people worked on this. And this is very, very good. What I want you to hear here is the support section is what's most interesting, I think, right? So if we look at the Spring Boot section here, this is the list of starters for Spring Boot that is working out of the box, right? So the support for Spring Native come this far that Spring Boot applications, the core of Spring Boot works out of the box with native image, but also a number of starters work out of the box with native image. And that includes Activator, all kinds of data access, JPA, Mongo, Neo4j, logging, of course, mail, RSocket, validation, OAuth, Webflux, Web as well. You can run Tomcat with it, some Quartz, and on top of that, the Spring Cloud things, right? So config, client server, Eureka, and so on, right? Those starters work out of the box. And you have to, like, if you know Spring, if you even heard about Spring something, you know that all those things and the Spring core uses those dynamic features of Java very, very much, right? So it configures everything through annotations and reflection. It creates proxies, and all those starters working out of the box should, if you think about that, should tell you that the team for those projects have figured out how to configure GraalVM for their usages of those dynamic features, which means that most probably you can figure how to do that for your application very easily, right? Right, so plenty of things work. There is also this Spring IoT plugin, which is kind of important thing. What it does, you include that plugin into your application, and then it will process your files and output the class file or the source file that will configure your application using the programmatic notation, right? So it will parse the configuration, those like auto configure like components and everything, and just figure out which starters need to be initialized, and it will output as a class. And then that class will be much, much friendlier to the static analysis of the native image than just the annotation-based config, right? So yeah, all those things are very interesting. I sincerely recommend you to read through that. There's also a section on how you can provide additional hints to the native image and Spring IoT configuration, where you want to use that. Very, very interesting. How to use the tracing agent and so on. But most importantly here, what we want to see is we want to see an example of a Spring application, right? And here it is. I have a sample Spring Boot application. I have also built it as well, but I will rebuild that in a second, right? So in the POM file here, what's interesting is that so here we have the Spring Boot Maven plugin. We classify that for the execs, so we don't do the fat jar. We don't do the fat jar. We added the Spring IoT Maven plugin, and those things come to you by default when you just do the start Spring IO, add the Spring Native, right? So it configures the generation of itself, right? And we also configured here, wait a second, we configured here the native image Maven plugin that will instruct, and it will run under the profile, and it will build the native image when we run package for our application here. So here, what I will do now, I will do run Maven, and I will do profile native image, and I will do package. I hope it works. Right. So this build will be, I think, a little bit longer because it specifies also that I want to run the profile clarity optimizations, but it shouldn't be considerably longer. So this code instance is connected to the virtual machine on the cloud, so it has plenty of resources. So it's supposed to be decently fast. I think it will take like a couple of minutes maybe to run this. But then after a while, I can run this application, and I can run it with the performance profile that you would expect from the native image, which it will start in like I don't know how much it will start. Let's actually see how much it will start for. It's the same cloud machine that I showed you those demos at. So if I go into the primes Spring, I need to go into primes and just run, for example, the primes Enterprise Edition Spring configuration, then you can see that it runs for, it starts in like what? In 70 milliseconds, right? And then of course I can just trigger that. Where's my browser? Demo 8080 primes random, right? So this is our Spring application responding to us with the prime numbers under 100. You can see here, so there is no trickery involved, right? If I stop this application, it stops responding. So it was actually that application running for me, right? So you can do that, and it works. And there are docs, and there are also some other materials And for example, you can watch. I recorded the video recently about how I tried this Spring application, and there are like a number of chapters that you need to understand, and it shows more documentation, and it's very, like, I think it's consumable, and that project shows a lot of progress. And I think if you're starting new Spring applications, you want to keep an eye on it, and you want to have the compatibility with native image in mind for that. So just as simple as that. And also, I said that like the native image build takes a little bit of resources. So recently, Oracle added the ARM machines to the cloud, which you can get also quite a powerful machine for free. So if you want, you can connect that to GitHub, or you can build your native images on that. I think it comes with 24 gigabytes of RAM, which is very often the limiting factor for building native image, right? So you can do that. And there are plenty of projects that use native images for various things, right? So you can build shared libraries, and you can add those shared libraries in your other applications. So this way, Oracle includes GraalVM for running JavaScript. Remember, the polyglot multilingual VM includes GraalVM into the database to be able to execute JavaScript in the database, which is a very fascinating project. But in a nutshell, it illustrates that you can take the native image and you can put it into your other native applications. There are a number of build tools which are command line tools, right? Which you might know about. So there is SBT, which is Scala build tool. They build the thin client for SBT that will start in milliseconds, and it will connect to the server and kind of say like, oh, build my project. And then you can do commands like that, and it's super, super responsive, right? So SBT is probably currently the most responsive Java build tool that exists, which is kind of very ironic if you think that SBT was very often thought of the slowest and the most sluggish, right? Maven D is a Maven daemon project where also the Maven process is split into the invocation of the client, which is the native image, and the daemon process, which will run with the JIT and do the actual work. And it offers you the similar performance profile. GraalVM native configuration, native image configuration, has been included in the AWS SDK quite recently, and I wrote a blog post about that, which is very, very cool. That means that you can use AWS SDK without configuring native image yourself, right? Which shows quite a bit of support and interest in native image. Lightbend recently rewrote their Kubernetes plugin from Go to Scala, and they run it as native image, and they're very happy with the results because on the code level, they can leverage the stack that they know and love, and it can integrate better with their other ecosystem for the projects, like tests and whatnot. But the performance profile is the same as with Go, right? And of course, people are running native image in the cloud for their web services if they want to kind of package those into the containers, right? And I will skip those couple of slides because that is a very advanced topic, experimental thing. You can also include the Java on Truffle, which is the GraalVM's other way to execute Java. You can include that in your native image, and then you can have like sort of a split where part of your application is precompiled the same way as you do with AOT, and the part of the application is kind of in the JIT mode, which is similar how you run it in the JIT mode. But that relies on experimental Java on Truffle implementation, and in general, this is a very, very, very bleeding edge. So normally you want to just precompile everything specifically for the cloud applications. There are a number of resources for working with native image. Blog post, I would encourage you to join the GraalVM Slack, ask questions, talk to us on Twitter. Just the team is very helpful, and we try to build a good ecosystem of the tools there and figure out how it works and help everyone. Right. As I mentioned, there are a free cloud tier on Oracle Cloud where you can get quite decent ARM-based VMs where you can build native images and also other things. So you can run your even a small cluster. I think you can run on those machines there for free, which you might want to check out if you want. As I think Borja mentioned, that there's the use of GraalVM Enterprise is free on Oracle Cloud, right? So that might be a very interesting scenario where you can both use the free resources on the cloud and get the to use GraalVM Enterprise with all its advanced features that you would like. But you don't have to use, of course, GraalVM Enterprise, right? You can just use GraalVM as your open source project, get the binaries that the team provides, and run it either as just a normal OpenJDK distribution to leverage the better JIT, or with the native image tool as well. So yeah, that's it. That is me. I hope it was interesting. I hope it gave some practical insight into some things that you will encounter when you start working with native image. And I also think that showing those practical things and sort of things that you need to understand didn't create the impression that this is something complicated, or this is something experimental, right? So native image is supported if you want to get support for that. And yeah, it just many people are doing that, and it's just something of like you need to understand certain things better to use it effectively. Right, that's it. Do we have any questions? Do we even have time for questions?
Yes, Oleg, there was like 3 interesting questions. One of them was precisely before you started talking about the Spring Boot and Spring, and I think it's more or less is commented because they were asking if everything was supported with the native image mode for the Spring Boot. Okay, so I think that you answered that question. At the end, they asked about if it's interesting, no, to take to bother you with this process. I think I was in the chat saying that some customers here at least have started this process because of the amount of resources they are saving. So it's very interesting in that, from that point of view. Some questions about the profiling and the tuning. That if it's so complicated, which options do we have for the profiling for the application in comparing with the Java traditional GVM?
Right. Yeah, that is a very good question. And first, so just to reiterate about Spring, right? That is an ongoing project. And probably if you have a very old Spring application, it will not be easy to run it as a native image, right? But if you are starting new projects, that is something that is much, much easier, because when you get to the level when it builds and runs, right, keeping that compatibility is much more straightforward than trying it on a large project and being then overwhelmed with like a number of issues altogether, right? Because then they kind of all jump on you rather than kind of revealing themselves one by one. So yes, that is the thing. And yeah, you can monitor Spring Native. I think with every release, they're getting better, and the ecosystem of the Spring gets more and more broader support for native image. So yeah, that is good. And then the question of the profiling, debugging, and everything. So debugging is available. You can build a native image with the debug symbols included. There is a support for that in the GraalVM Enterprise. There is also some support for that. I'm not sure what the extent of it in the Community Edition that you want to run if you want to try that. So far, I don't think I've seen many people debugging native images like that, right? It feels that this is important, but nobody wants to do that because the native image is a native application, so the tooling is also native. So you're going to debug that using GDB. And normally what you want to do is you want to actually debug your Java application running as Java application, and then native image just compiles that the way it compiles, right? So there are very few cases where it compiles and then you have to actually figure out what is happening inside. And for those, you can use the debugger. And there are so the possibility is there, but I've heard of a lot of people doing that for the native images, right? And profiling, you can also use the native profilers like VTune, for example, and you can check the GC logs. GC is something that people very often tune for native images. You can, yeah, but native profiles is what works. I think perf works as well, right? I've seen at least some articles about using perf with native images. So that's that. Monitoring also works. Monitoring specifically because in the cloud, you don't actually maybe profile that much, but you mostly want to monitor things, and then you want to scale maybe ahead of time, right? Because if you see that the resources are getting slimmer. Monitoring works, and you can include the monitoring libraries. What doesn't work there is the Java agent-based approaches, right? So what you want to do is you want to include the support for the monitoring in your application as a library, for example, micrometer or something, and then those would be sending the metrics somewhere, and that will absolutely work. But attaching those things dynamically at runtime, there's just no capability for that, because that includes that requires dynamic code execution at a runtime, which is just fundamentally not there because everything is precompiled. And if you didn't think about that ahead of time, native image cannot do that, right? So yeah, so those things are a little bit different. And maybe if you worked with Go, I think maybe it resembles a little bit how you debug, profile, and monitor Go applications. But it's a little bit a different approach to how you normally do with Java applications. But it is possible.
Okay. They have asked us as well if we wanted to use the Spring Boot with GraalVM in Git mode, any Docker image in special. I mean, I posted the GitHub GraalVM
Yes.
link. I don't know if you have any other suggestion.
No. So like there are Docker images on a GitHub Docker registry. GitHub container registry for the GraalVM Community Edition builds. As far as I know, there are currently no builds for the with the Enterprise Edition that you can just easily use. So, but you can easily build that yourself if you would like, just to experiment and run with it. The Community Edition gives the performance impact there is also kind of like sort of simple. The Enterprise Edition will run faster, most probably for any arbitrary code, right? So for the Community Edition, I would recommend you measuring the impact. Absolutely, right? So there are some code bases which have been heavily optimized for running with C2, which is the default compiler, top-tier just-in-time compiler in OpenJDK. And then if your workload is mostly bottlenecking on using that code, then C2 might be a better choice for you, right? If your code is mostly bottlenecking and the code that needs to be optimized more is your code that you like, your application code, right? Then most probably GraalVM compiler will give you substantial benefits, right? And the same thing is, for example, that's why GraalVM shows such interesting results for Scala and Kotlin and other JVM languages, because they produce a little bit different bytecode patterns compared to what your Java application produces, right? It's the same like valid bytecode, right? But it's a little bit different. So when compilers looks at that, maybe it doesn't see the exact same patterns, or there are some other things that it cannot optimize that well because it just hasn't been optimized for those workloads that much, right? That's why GraalVM shows excellent results on those programs in other JVM languages, and that's why also it shows really, really good results on the code that you write as an application developer, because that is not the code that has been in the ecosystem for like 25 years. So C2 didn't have time to learn how to optimize that particular code very well. and a more powerful compiler can give you the benefits there. So that is sort of the general advice, right?
Okay. So I think it's enough. Thank you very much for attending, for being here today, Oleg, and all the attendees. I'm going to switch to Spanish. Muchas gracias a todos por asistir y simplemente recordaros lo que os he dicho también en el chat, ¿vale? Que la cuenta esta que estábamos comentando era Always Free, la capa gratuita, ¿vale? Incluye, como comentaba Oleg, la posibilidad de tener hasta 4 instancias de ARM, 2 de AMD, 2 bases de datos. Al final, yo creo que como desarrollador, yo siempre pienso que hace unos años, ¿no? Como me hubiese gustado a mí tener esta capacidad de tener, ¿no? Ese tipo de recursos de manera gratuita y bueno, incluso sin ningún tipo de coste, ni ningún riesgo también de que se vaya a cobrar nada, ¿vale? No se va a cobrar nada ni dentro de un año ni dentro de nada. O sea, podéis tener ahí, yo que sé, vuestro blog personal, lo que sea, cualquier cosa, os animo a que entréis y lo veáis. Si queréis que os haga un whitelisting para que tenga una promoción especial, podéis mandarme un correo al correo que he puesto en el chat. Gracias a todos y gracias a Paradigma también, por supuesto, por hacerlo posible, y estamos en contacto.